Anyway, I'll try again. Yeah, yesterday I presented our product and the database level, or the persistence level, the database we create especially for that project, and that I want to present today. Yeah, when it comes to database, it's super weird because the more presentations I do, the more I think is I'm never been a database guy. So for me, it's almost like I did not choose the database life; it chose me. So because it goes really, really far, and I always had, as most of them, people that do services have to deal with databases. And in all the thinking, I'm always I'm always trying to imagine what would have happened if the industry came up with a memory that is non-volatile, fast, and cheap. Because so no offense meant to anyone, but databases are a pain in the ass, actually, because it's really difficult. It makes everything complicated. And sorry. Yeah, and I would like to see a world where the database would just not exist because the memory wouldn't be volatile. So, I mean, we have an image kind of thing. For me, we were close to that imagination, but and James, no offense meant, but for me, if you have to have a database, it should be a library. Another product. I think there's people they think the different. We call database vendors. But my vision of a database is always like trying to at least reduce the complexity, and that's what the talk is all about. Trying to prepare. I just came that it's now 40 years of database for me. I remembered doing someone 40 years before. It was for a friend of mine or the friend of my brother. And I had a C64, and you remember this data set, the music cassettes. And there was a paper notebook where the records, you have this counter on the side that you have fast forward and stuff. And you have a book where the record is the counter, and then you just do fast forward to the counter, and then you could read the record. And I just recognized that the principle didn't change within 30 years because there was indexing. It was just a binary. Well, if I would have rewritten the notebook alphabetically, you would already have it back then. So my history, my path of pain, it started actually in '95 doing a lot of stuff. MSQL. Most younger people think it's a typo. It's not. It was a super simple single-threaded database, but it was the only one affordable in open source and stuff. Later, there was the typical MySQL, Oracle, Postgres, any SQL database you can imagine. And then 2005, we did a startup with, and then with Squeak, that was the first thing I said yesterday. And there, I tried to avoid that. So I got through GUTS, which is one of the old object-oriented database incarnations, one based on Squeak. But in the end, it was far too slow. It didn't work. And then I went back using something like Glorp. And people that know me, they know I hate ORMs because the misconception and they just don't work. No offense. Later, we just, when I got doing services on the net, there was the combination that we have is using MongoDB. MongoDB lets you at least have nested stuff, have no schema. The data is treated a bit more relaxed. So, and we have Voyage or Voyage, like the creator, Esteban, it's an Argentinian, would say is an object mapper onto MongoDB. So it's ORM just slightly better. It just has a bit less of pain. But in the end, so the product that I presented started actually using this, and then I was, for several reasons, I was not really happy with that. I mean, all the databases, if you look closely, like SQL stuff, they have all these, I mean, if you know C, or I'm always remembered about Corba, because you have all these stuff where you have 5 types, like numbers, floats, strings and stuff, and then say, come on. If we do a product that pretends to be a database, there will be an impedance mismatch sooner or later, just hooking onto another database. So we need something better. And that was the very start of Soil, saying we can do our own object-oriented database, and we just save a lot of headache and get away much faster. So just for you, quick fun comparison. What I'm talking about is like there's MongoDB, Postgres, SQLite is the exception for me, and Soil. So everyone, when talking about databases, thinks that the nature of a database is that you send your data over a network, but that always misses the point because it makes everything complicated. You have something to map on SQL and you send it back and forth. But people always think that's a database is always to send data over the network. Two ones that don't, SQLite and so. The next thing is the query language you use. It's always you have a programming language, which is Smalltalk or Java, whatever, and then you have to map into some alienated query language, DSL, which is always a pain in itself. So, and then Smalltalk. I mean, we like Smalltalk. Why not just use Smalltalk to do it? And then finally, I mean, this also results to that actually there's only one choice for me. Mañana. All right. Where we are right now, it's like James was talking about the currency of databases, usually called ACID transactions, which means just it's very, very unlikely to lose data or to corrupt your database. That's in a sense is it. So it gives you a bit more of security. Then there is something like called MVCC, multi-version concurrency control. That's the state of the art, which almost every database does. I will present a bit what it means. Then we have also some binary search, like skip list and B-tree, because if you have a lot of data, so you need to have fast access and conflict-free access to that. Object segments is something we just introduced. So there's two segments right now. There's segment 0 for all behaviors. So yeah, that's it. We also put classes as objects. And then there's segment 1 for the normal stuff, but I imagine having different kind of segments later, maybe even remote database, Redis, whatever. So we did it from the beginning. Yeah, so ACID transaction. This is, if we just use Soil, it's like downloading a Faro. It's from 11, 12, the newest one. And then go to GitHub, load the repository, and you're done. That's your database installation.
Thank you. You said that it doesn't use network communication and that it supports concurrent access. So, right? So, is that concurrent access from several processes in the same image, several images in the same machine, different machines, a broker? How do you handle that?
Yeah, so that's back to the product a little bit. So it's like SQLite. You just have local. Well, you have file system access. In the product, we use a network file system to share the file system across the hosts. But I hope next ESEC or Smalltalks, I will present something pretty more, which even eliminates that, because the Soil is about to go as a distributed database, and then you're not just share, but you distribute data, and it resolves a lot of the problem. So, but now we use a network file system, and that's just good. A network file system that supports range locking, it's called, and we're back to NFS, the good old, ever been there, usable for everything that we use. It's a simple approach, and it works. Yeah, so that's the basic. After you got your repository loaded from GitHub, you can open a workspace and right away make something like you have to create Soil and then make a transaction. And there is like in the Smalltalk image, you have a special objects array, the root objects that that's the one that will not get garbage collected, and everything attached to this stays in the image. Same thing for a database. I think in Gemstone, there's barely another way to do it. Like you tie it to something, and then it doesn't fall down. So and that's the 3 lines. Is just if you want to just make a dictionary into the database, transaction, set it as root object, commit, done. The thing below is that the asset quality about it is that you have a 2-phase commit. So the one thing is committing the data. The other thing is modifying the database files. So a journal is usually a sequence of changes you do to the database. And that's synced for sure. When you commit a database, these needs to go to disk. So there's even pushing the operating system to make that. And then you can take your time to change the database files, because if you then crash, you can detect that there is a newer change and then can replay the journal. That's why a lot of databases call it replay log or replication log. And so we can discuss, but it's hardly to go in between. It's on disk, and then no matter when you crash, either it's gone because the transaction just didn't make it. If you commit, it's on disk. Then there's a checkpoint. That's what usually means, that the checkpoint that all the data is actually in the database files. So because even if you go to the database file and saying that there's something new, you can scan the log to saying I'm applying the changes in memory, and then I'm also on the newest state. So that's the incarnation of ACID, I would say. Maybe James would agree or not. Yeah, multi-versioncy concurrency control is well, it's a bit exhaustive, but it's a super feature that means just that every time you change something, you write a new record of that thing. So it's append only as well. So appending is much faster in most disk activities. So you write a new object at the end of the file, and the old one still is there. And that means that if you open a transaction, you pinpoint a whole database to that time and that version. So even if someone commits something in between, then you go there and they see, that's not, I'm not allowed to see that, but this has a pointer to the version before, and then it goes down until saying, okay, this is the one I could see, and that isolates your transaction complete from every other commit, so that you can just have a consistent state, and that's what you want. So that's usually and that's also what makes most of the database stuff happen. Is most of the soil code, because it's really heavy to do, especially if it comes to binary indexes. Yeah, and the time travel, that's a side effect of doing MVCC. I will for Henan, I will demonstrate that as well. Yeah. Just we have 2 binary indexes. I'm the guy, I didn't do computer science and stuff. I'm a lazy guy. I like the cool and lazy algorithms. So that's why I implemented skip list and Marcus did the B tree. Because the B tree, that's the one thing you will have in computer science. And the skip list is just a very simple thing to do. It's just a stacked linked list stacked above, where you just you flip a coin. And then you say on each, you flip more, statistically you go down. The characteristics is also that the search speed is O log n as it is in B-tree. So the characteristics are almost the same. The implementation of the skip list is way easier. And for what we do, it's because in a B-tree, it always needs to balance. And that's a lot of access. And the skip list is just lazy. It's like if you're on the same page. So we made a skip list. 100% skip list because we do file paging. So that's the thing that writes is the smallest amount of data read or written from an operating system is 4K, depending on the operating system. So you always align your memory and that 4K saying when I write this, it's the same the operating system does. So you have the speed you get out. And so for us, the yellow line would be file pages and the skip list go on top. Then we have a B tree, which is the usual stuff that you have. When you insert stuff, you rebalance your and have the same characteristics to binary, have O log n lookup time. Great. All right. The font is big enough, I hope. It is. So yeah, here's a bit of basic API. When you start with soil, you create a database on a directory. You just make a directory name and then it creates it there. You can open it, or if you go and play with it, you can just make this and then you just remove it, create it from scratch every time. It goes super fast. We have 2,500 tests, and each of the tests on RCI creates a new database. So that's something else that I need to mention, which sets it apart from usual SQL database deployments and stuff, because you can't do this. Then it's the same thing I had on the slides. You can have, so with this, we just make a new one, and then we set it a dictionary. Then there's someone coming, adding a key and a value to the dictionary, and there's another one adding that. And in the end, you make the new transaction, and then you have the dictionary. It's, I mean, there's nothing to show here because it could be fake. It would look like the same. What is the difference is that if we look at the database, we can now see the database version is 3, so that means there's already 3 transactions that we did. Application version we put for, so you can have your own model versioning. And we can also look at the journal, which means there is one journal file, which I just created. If we go into this, we see there's 3 transactions, and then we can look in each transaction, we can see the log. So it started transaction, then there was a new object, then it updated the database version, then there was commit. So the second transaction, if you see here, there's just the second line changes because now the first time the dictionary was new, you write a new object, and now there's a new object version entry. And so you can, looking at soil, you can go down to the byte level. If you see this, you can even go into the entity, and then you just say, in the end, what you do in the database, you exchange one byte array by another one, because everything, the whole object clusters are serialized to byte arrays. And when you write a new object, you just write a new one in order to do the reverse replay, so undo. We keep the old bytes. So because then you can go back in time, you can just say, okay, databases don't remove stuff, but if you re-add the old stuff, you will end up in the same state as before. So that's the usual thing how databases work. No, I'm not sure when I started, but so that's the most basic use. 10, okay, that will be fine. Then there's another thing, because we just added a dictionary, and you can imagine if you have an object graph, it could be really huge. And one thing in every database like Gemstone is not to have the full thing. So in a database like an object database, you have one thing that is, we call it a cluster, objects that are kept together, and each cluster has an address. So, but every object you can make standalone, having its address, which means you can partition your object model in, and that's on an application level. So the application developer decides what to partition. I'm just taking the example from the demonstration yesterday. There are some developers, and I'm creating a few issues, add them to the collection, and here down there I'm just saying that the 2 issues I'm creating and the 2 developers, they should be roots or standalone objects, that making them not going into one thing, but each of them getting an address in a database. So now they're in, and now if I open a transaction and look at the first entry, you just see there's an issue and there's an assignee. If you look at the real class, then it's a proxy. So that's the thing that you have. You write a cluster, and either the object is included, or you get a handle, an address to which object, just like it's in the VM or something. You get an address, And when you read a cluster, each address is exchanged by a proxy. So the time that's, I had to add a real class because in the inspector, there's no way, because if we go here, you don't know this because you have the proxy, and with this kind of inspectors, there's no way the proxy implements all of the methods. So it will trigger the proxy, it will get the object. So, but that's a good thing that if you have a soil database and you have a huge stuff, you just go in the first object and then you just click through like in a normal inspector, and it will transparently load the objects from the database. And that's super handy. All right. Yeah. So yet again, so we have objects and clusters. So meaning every graph that is consistent is written to a cluster. So all together in a byte array. And if you make them have distinct addresses, you partition the model. Sure.
You showed before that for an object to be committed, you had to mark it as dirty.
Yeah.
And now you're showing proxies that could do that for yourself. So why do you have to mark an object as dirty?
You mark when you modify it. So,
yeah, but why? Yeah, but if instead of having the real object, you use a proxy,
yeah,
you could go through the proxy, and every time it changes, you know that it's changed. I mean, to make the mark dirty,
yeah,
transparent. I don't know if you thought about it or.
Well, when you develop it, there won't be proxies. So because you always do the object. So even with Voyage, I didn't have the time for now. I have some things like there was you can have a write barrier.
Yeah,
we have read-only objects. There could be stuff, but I just didn't. So, but you're right. That's the one thing I don't like about Soil, because it makes testing and example objects a bit complicated because you have to use the low-level API. So there's also for the make root, I just make it for demonstration. You have a class side setting. So you can, per class, you can say this is all instances of that class should be root. But the power of the database is that you can put this standalone thing on each object, on each instance. And yeah, I'm not yet there to,
cool.
But I want to. But still the making it root is something which is application specific. So you might make it in another way so it gets out of the way. Yeah, but it's the main pain point because I'm trying to do example-based testing. But it goes always in between.
Okay.
Yes. It's not finished yet. That's the start. All right. The next thing to demonstrate would be something where you actually, I think even Gemstone, you always struggle a little bit if you Smalltalk and you want to all keep it Smalltalk. And then at one point, I think Gemstone had this curly brace syntax or something. You need to have something index specific moving in there. We just made it super blunt in the skip list dictionary because we do file paging. The optimization is you give it a fixed key size, and then you choose the number of the skip list, how many levels it has, which is more or less the if you take the it's 253 log 2 times. So you just say the expected amount is 1 million objects, and then you just can do the calculations, and then you know probabilistically this many level will be performance-wise will be the best, and you can readjust that. So that would be the way that you just create something like a binary index, so a dictionary which is a binary index attached, so it keeps the basic dictionary protocol, and underneath there's a file index which is binary. In order to do this, I'm just made a simple example where there's 100 processes, so there's fork, so there's 100 processes just making transactions and adding a key. So to see that, you can look at the control file. There was 101. So the first one was the skip list dictionary, and then there was just 100 per processes. So that's while concurrency, they all run. There's a semaphore protection, and the transaction is just streamlined. That's like in every database. So you have the writer problematic, we call it, You have only have a single writer because if you have two, they can stomp onto each other's feet. So you have everything in parallel until you really go to this or really commit and assign. I mean, you have always these addresses in the database. You have to do this at the very latest point because you cannot acquire these soon. All right, let's hurry because Hernan wanted to see. So yeah, so same thing. Again, you have the developer objects, and then you have issues. Then you assign the second issue, the first developer, and then oops. And it's jumping. Did I execute this? No, I'm not sure. Doesn't matter. So you can just look at it, and then you have the second issue. There's a assignee. Now it's Marcus. But as we have each state of the database has a version. So that's every commit advances the database version. So that's a sequence of changes and states. And with MVC combined, I can just make a transaction saying, just to show you, we have now the awful. If you look again in the database, there's now 3 connect. So that 3 was the last, so I just go 1 back. I'm just selling the transaction. So you pretend now to be only read version 2. That would be the case when I open transaction, someone else commit something, and I'm still on version 2. And then you do this, and if you now look at the developer, that's me. Because now the reference to the stuff just went down the version, and that works all over the graph. No matter how big it is, it will just give you a consistent view of everything you reference, which is super cool and not possible in most other databases. All right, so that was the short demo, and the wrap up would be that, of course, we do a product, and I would like to spend a lot of more time into the database, but right now, so for MVC or concurrency to really work, we never remove something from the index. We just mark it, delete it, because I need to explain, because you have one database that removes a key and another one had opened a transaction. You still need to, because the index are central, they're global. So then you go back to the journal saying, was there a change in between? And say, yeah, they removed the key, and what was the old key? And then you present it to give the consistent view. And this is really hard to do. I mean, that's most of the time we spend making these models. Then multi-index collection is something which you use in a SQL or in any database. It's just you have multiple indexes. The one is by first name, last name, whatever. So you will have object index in a different way because it's a binary index. It just works on one, well, either on one single key or compound keys. That I still need to add it. So there will be a dictionary where you can say every object with, we could specify an accessor, like every object that's been added, you call the accessor, and that will be the key to the stuff. So you can have multiple keys. The counterpart will be query planning, because you don't want to specify which index to use. So you will have just a Smalltalk, like a selector with a block. And my current idea is just to take the AST and look for the methods you send, and then you know the properties you want to acquire, and that would enable you to figure out which is the best index to use. But it's a bit far. And garbage collection just started, so we also don't. So the biggest database right now is 90 gigabytes, because I think the real data is maybe 100 kilobytes, but it does a lot over the last year, and so it's 90 gigabytes. And I have the first incarnation of a garbage collector, but no time. So, but it will come. Yeah. So garbage collection is always like in a database, you can have so many levels of cleaning up. But yeah, and the good thing about Soil is that the way the database works with the cluster management and the object is completely separated. So so garbage collection, you could do without having the application code loaded. So because everything like referencing and everything is mapped onto database level, so that the byte arrays that are on the disk are never consist of any information of the database and vice versa. So, all right. Livin. Any
Hi.
more questions?
Yes. So I missed how you mark things modified. How does that work? How do you do modification to mark an object modified?
There was a mark dirty call.
So you do it explicitly, right?
Yeah, that's what I'm saying.
Right.
That's what I don't like,
Right.
because that's not good and it
No.
makes it complicated. Is now you have to mark dirty. So, and it's especially complicated because you make this clustering. So you have to think about that root object. You have to know that, because the dirtiness goes on the cluster, not on the individual object. So that's
And you know how the glop thing works, right? With the read-only object.
How what?
Shallow glop works by having a read-only object and a shallow copy of the original, so that you can do a quick diff.
really. Oh,
It's
yeah.
very simple. So then, what are object segments?
Pardon?
What are object segments?
It's just the way, well, pretend we will need that in a second, that we have, because, well, an object address in the database is like segment plus index. So it's just a preparation to have to I mean, I love having heaps, well, separated. So there is different needs for different objects. So that's the one thing in the segment 0 for all the classes or the behaviors just exists because it doesn't grow that much. So that means the index, the address will be really small. So, and that's just an optimization. And so then everything, usually the heap goes in segment 1 but we just put addressing and the segmenting so you could, because that to introduce that later will be really hard. So we just made a preparation because I have things like remote stuff and that you just have. I mean, a segment is like an MMU. Like there is one that takes responsibility to get you the thing you want. Yeah. But you just ask to it. So in the segment, it's more, you can have multiple entries and you don't care how these objects are stored. You just say, give it to me or take it. And that's the same thing. I always tell a story because how I got the same database, the same thing 100 times faster was 10 lines of code. Because there's in the segments, there's only add put and add. Yeah. So there's only one method that writes that goes to the segment and one out. And so implementing an index was like making a subclass, override the two, and then say least recently used cache, add if absent put super add. Yeah. That was the whole 10 lines, and that reduced the number of disk operation to 1%. And that's what I really think. If you do this in a Smalltalk way and the database, right in there, you see how easy it is to make something really powerful. 10 minutes, 10 lines of code, huge effect. And that's usually with a distinct product in binary form that you don't have access to. It's really hard to do, and you just need to walk around. And that's something I didn't like. Any more?
Yeah, here, Norbert. My question is similar. I think someone asked while you were talking. It's about the deployment. Yesterday you say that Aptic Read had multiple Faro images. I suspect or I imagine those multiple Faro images may reside in different machines, in different nodes. So how would they talk to a soil database? So let's say I have one image, because the way that you show in the code is accessed via file system. But if I have let's say 10, let's say CSI or 10 whatever worker, 10 images in 10 different servers, how would they talk to the one image with soil?
There is no one image. The architecture is about having every image is the database.
Okay.
So every application code directly accesses the object, and the database is just a mediator between the disk and the image. So what we do, you cannot do everything. So for me, I can go on endlessly, because people always have to argue. It's like you have 5,000 databases, so how you dare? So you have to back up 5,000 databases, and we're saying, well, in theory, it's 5,000 with the size of 5,000th of the size, so it's the same thing. But then I get back. But I just back up the database that changed, and you just back up everything, the whole bunch. So, and the architecture so everyone expects the database to be far apart, and the same goes for sharding. I mean, everyone talks sharding, but sharding is two design flaws in one. So first, they have multiple customers, they put it in the same database, then they invent something called multi-tenant, and then, because it does not scale, put sharding in front to virtualize the ID range. And for AppDiv, just saying we partition on the user level. So I mean, each user is its own database. A Faro image can hold, I configure this, any amount of databases. That's the point. If soil is, there's 20, 30 databases in an image, I have 12 images per host, I have 3 hosts, and I have a load balancer that just pins to one ID to one database. So there's just the deployment. You can fine-tune saying there's 1,000 people, I have 30 images, and each image has 50 databases, so you will...
So those 12 images, they all access the same path on disk for that server?
30. So for each database, one. You have,
okay.
For each user that gets to that image, will open its database on its path, but you can have 20, 30. It's not... Okay. That's what I see. People are so tied to have one big monolith database and stuff. No, the database is just to store some data, and I want to have it flexible that you really have any amount of users, any amount of machines. The mapping is just the deployment stuff. How much memory? If I want to have a big cache in the image, what I did with the least recently used cache, then I will have less databases. But you will always fine tune. But it's just an association from each user or partitioned model to one database, and you're completely free how to put it. Does this answer the question?
Well, great presentation. Something that you didn't mention, that it's like this has some heavy resemblance with Omnibase. With Omnibase?
Yeah.
And I know this doesn't work in Windows.
I know. Yeah.
So what is the first question is, given that Omnibase did work in Windows,
yeah,
and was actually used for the storage in Dolphin and everything, yeah. Why it doesn't work in Windows? What's the current limitation?
Okay, what I did not say is the very start was Omnibase, because I just discovered it. Well, back then I thought Omnibase was just a big monolith as well, and then I just discovered, oh, that's just all Smalltalk. And then I took it, maintained the code, and that was the first one that changed, because the file handling code was such a horrible thing. I mean, Omnibase is not, well, the code quality is rather poor, but the file system handling was awful. And you see everything, the Microsoft factor, every shit they did in all decade and they want to keep, you had to, they creep into your stuff, into your API. And I never used Windows in my whole life. So I'm just saying, I cannot do it. I don't want to do it. If you want to do it and you assure me you will maintain it, that's what I wrote in the email. I'm open for Windows. If it, open source is like, you can do it, but if you just do it and then you don't keep up with it, I have to do it. And that's something like, so there was one user that tried it on Windows. So there's only two things. There is range locking that, well, for normal database guys, it would come like row locking or something. That means that you have a position from to in a file that you lock, because optimistic locking is not like you not making the biggest lock, but the smallest possible. That's using a POSIX call, which is called FNCTL. And that's not implemented for Windows, and I don't know what. And the other thing is the sync fsync it's called. And that's because if you do a flush on a stream in Smalltalk, it just gives the data from the image to the operating system, but that keeps it in memory until it decides to write it to disk. And we're saying for the journal, you need to have the assurance. They're saying when the committing ends, I need to have the assurance it's on disk, otherwise the whole assumptions fail. and then you put it fsync. And that's the two things that fail. In the meantime, I made both of them configurable to be switched off. But there was some, I'm not sure what he did wrong or does not work. Well, he said it almost works, but for his case, it worked on Linux, but not on Windows, but I could not see, well, I would be interested in finding out what that is, because that seems to be a really small thing to change. So you can just, if you want to use it on Windows, just say, I don't need locking. So if you have a single image and stuff, you don't need that. So there is even image locking, yeah. So you can switch it off, and then we can see. If the Microsoft file system API is not horrible, which I don't think it is, well, I think it is, but then yeah, I just don't want to spoil the whole product just because of Microsoft, because I really have no deal with Microsoft so whatsoever. Quite the opposite.
Just before you leave, question is related with the clustering. It's like in your sample, you have like a developer instance and an issue instance, and I don't remember exactly, but I think in the dictionary, you store only one of those, and you mark dirty one of those.
Yeah.
Let's suppose you want to have some sort of collection, so you can directly access the list of developers and the list of issues on two different keys on the root dictionary, and you save the issue that references the developer. How you solve that? How do you dereference everything, or everything goes in as a single cluster?
I have a hard time following, so I
can ask you outside. Don't worry, because we have to go lunch.
But yeah, the restriction is that for now you have this in one image. There's no sharing for now.
Yeah,
I will
that's right.
add an option not to use the cache, so you could actually, the image doesn't cache and there's file locking, so it could work. But actually, if you add caching and the logging, you will be 100 times faster. So it will still be better to have one image than a few others.
Okay.